Francesco, and today we will solve an A-level mechanics problem. This is the problem. There is a ship being pulled along two cables attached to two tugs. We know that the tension in each cable is 6,500 newtons, and we know that the alpha angles are both 35 degrees. And also we know that the ship is traveling with constant speed of 1.5 meters per second from the left to the right. We are asked to calculate the resultant force exerted on the ship by the two cables. Then we are asked to find the work done by the resultant force. Then we are asked to discuss why the kinetic energy of the ship is not increasing despite of the work done by the tension. And at the end we have to discuss what happens if the alpha angle is reduced while the tension remains constant. So let's start from point 1. So basically we have to calculate the total force acting on the ship. So we have that the total force is just the vectorial sum of the force T1 and T2. So with the picture we have x-axis, y-axis. Let's say that the origin is the point O. So we have T1, this is alpha, and then we have T2, and this is alpha as well. Well, so we have to write down T1 and T2 in components. So about T1, we have an x component, and T1, a y component. The x component is given by T1, the modulus, times the cosine of alpha angle. While the y component is given by T1, and this time we have to take the sine of the alpha angle. About T2, we have also a component x, then a component y, and they are equal to T2 is again T2 times the cosine of alpha, and this time Ty2, so this component is minus T2 sine alpha. Okay, so we can put all together, and Ft, the pulling force, is T1x plus T2x on the x component, and T1y plus T2y on the y component. Namely, T1 goes alpha plus T2 goes alpha on the x component, and T1 sine alpha minus T2 sine alpha on the y component. But now, since we know that T1 is equal to T2, this is just 2T cos alpha, where T is T1 or T2, we can choose. And here, they just cancel out. So the force is just F T along the x direction, where Ft is equal to 2t equals alpha. And if we plug in numbers, we obtain 6, 9 Newton. Okay, so this is the pulling force, which means this is the resultant force coming from T1 and T2. So let's move to the second point. And since the motion is linear and the force is constant, the work done by the pulling force Ft is the product of the force and the space displacement. And since the motion is linear and uniform, the displacement is just the velocity times the time. And yeah, I forgot to say, we are asked to calculate the work done by the pulling force in 1 minute. So delta T is 60 seconds. So if we plug in number, we will find that the total work is that's it. Okay, so let's go to the third point. In order to understand this fact, we have to consider all the forces acting on the ship. On the ship, we have not just the pulling force Ft, but we also have the friction force coming from air and water resistance. So let's say F friction. Okay? From the second Newton's law, we know that the total force must be equal mass times the acceleration. But in this case, since we know that the velocity is constant, the acceleration must be 0. So the total force acting on the ship must be 0, which means the sum of the pulling force plus the frictional force should be 0, which means that the pulling force and the frictional force have the same modulus, but they have opposite directions. And so, if we consider the work done by the frictional force, it is just minus force, the modulus of the force times the displacement, where this minus sign comes from the fact that the work done by the frictional force is against the movement. But this, if we use the fact that the modulus of Ft is equal to the modulus of Ff, this is just minus Ft delta S, which is where Ft delta S is exactly the work done by the tension, by the pulling force T. So we have that the work done by the frictional force is opposite to the work done by the pulling force. So, if we consider the variation of kinetic energy, the variation of kinetic energy must be equal to the total work done on the ship. So in this case, the work done by the pulling force and the work done by the friction force. But if you use the result we have just obtained, this is just which is equal to 0. And we have proved that the kinetic energy is effectively conserved. And it means that the work done by the pulling force is spent to keep the ship traveling with constant velocity against the frictional force. At the end, let's consider a new angle, let's call it alpha prime, which is smaller than the original angle alpha, and the tension T1 and T2 is still the same in each cable. So since the two angles are smaller than 90 degrees, this implies that the cosine of alpha prime is bigger than the cosine of alpha, which means that the modulus of ft prime, which is equal to 2t cos alpha prime, in analogy to what we have done previously, this is bigger than 2t cos alpha, which is what we have defined ft, which means that the modulus ft primes is bigger than ft. So with this relation, if we remember this Newton's law, this time the equality ft prime plus f frictional is not satisfied, because ft prime is the modulus ft prime is bigger than the modulus ft, and this means that the acceleration acting on the shape is not null, and in this case there's a positive acceleration, so the ship is increasing its velocity, at least until the frictional force will counterbalance again the pulling force. Thank you.